Good morning. Welcome to another session of MCN 201 Sustainable Engineering. In the last session we had seen circular economy, and in this session we will see biomimicking. Before we proceed, let us see a quote by Mahatma Gandhi. You must be the change you want to see in the world. What is biomimicry? Biomimicry is an innovative methodology to observe, inspire and value nature, to learn from it and find and derive solutions from natural models to solve human problems. The aim of biomimicking is to explore, study and develop sustainable solutions by imitating nature and develop appropriate strategies identical to those of natural elements in order to resolve a particular problem. Biomimicking has been seen from early 1903 from Wright brothers, and in 1969 there was a paper titled Biomimetics, and so on. You can read a lot from the book Biomimicry, Innovation Inspired by Nature. Biomimicry has basically three components. Nature as a model. So we can imitate and inspire from natural models. Nature as measure. We can use ecology as a standard to measure, and nature as a mentor. So it is a new way of viewing and valuing nature. 9 basic principles of biomimicry we will see one by one. Nature runs on sunlight. Nature uses only the energy it needs. Nature fits form to function. Nature recycles everything. Nature rewards cooperation. Nature banks on diversity. Nature demands local expertise. Nature curbs excesses from within. Nature taps the power of limits. So each one of them we will see with an example. Nature runs on sunlight. Without sunlight, plants, vegetations, insects, reptiles, animals and human beings cannot exist in this world. Nature runs on sunlight. This is a picture where you can see a house built with the roof is completely solar. So we too can live completely depending on solar energy. No need for energy from fossil fuels. Take only what you need, not as much as you want. This is the second principle. Nature uses only what you need. Nature fits form to its function. You can see these two pictures. The long neck of giraffe is designed for its food habits, to eat vegetables available at a very high position. And here a bird, you can see its beak, it's designed, or it fits its function. It's designed to suck honey from inside the flowers. Nature recycles everything. Everything produced in nature is biodegradable. So it is, everything gets recycled. Nature rewards cooperation. See the birds flying in a pattern. By flying this way, it has to encounter lesser resistance from air. Nature banks on diversity. Diversity is very important. Nature demands local expertise. You can see a group of elephants flocked around a female elephant who is giving birth to a child. Survival strategies drive local expertise. Elephants huddle around female to protect her from prowling hyenas while she gives birth. Nature demands local expertise. You can see this goat sitting at a very high altitude. Without specific expertise, it's impossible to reach there. This is another picture from Canada. Barnacle gosling nests at heights of 400 feet to protect its chicks from predators, primarily foxes and polar bears, but also away from food. Nature curbs excess from within. Forest fires are a great example of a natural phenomenon that renews and refreshes, cutting down on excessive growth and allowing for regeneration. All living things are governed by limitations. Age, climate, population density, and many other factors determine how species and systems develop. So nature taps the power of limits. Here you can see a submarine built mimicking fish. This is a news from Massachusetts. 4 feet long tuna fish shaped autonomous underwater vehicle designed to blend in with undersea life and perform compact. There are many examples which are inspired from nature. You can see the first picture, energy efficiency, learning from nature how to create flow without friction. And the third one, another design, how does nature attach and detach. Learning from plants how to clean without cleaners. You can see the example here. Biomimicking is used in architecture also. Nature, learning from termites how to create sustainable buildings. Passive climate control in the Eastport building, Harare, Zimbabwe. So how passive cooling without energy can be attained has been implemented here, mimicking termites. Transportation, how does nature travel quickly and smoothly? The bullet train in Japan has been inspired from birds. Climatic change, learning from human lungs how to sequester carbon. Agriculture, learning from prairies how to grow food sustainably. Identify the real challenge. Don't ask what do you want to design. For example, an air conditioner, ask what do you want to design to do? Make people feel cooler? Ask why multiple times. Challenge. Air conditioners use a lot of energy because they use heat to dry desiccants that dehumidify air, and then they must cool the heated air. Why use desiccants? To dry the air. Why do the units dry air? Because high humidity makes air feel warmer. Why are they using heat? To drive the moisture out of the desiccant so it can be reused. So you want to design to pull moisture out of air and cool the air. Develop a design brief for the needed function. Biologize the question. Identify functions. Does nature do that function? How does nature not do that function? So ask all these questions to yourself and then reframe questions with additional keywords. Define operating parameters, climatic conditions, nutrients, social conditions, temporal conditions. How does nature perform this function here in this ecosystem? Integrate life's principles into the design brief. What are life's principles? Life creates conditions conducive to life. optimize rather than maximizing, leveraging interdependence, benign manufacturing. Life adapts and evolves, locally attuned and responsive, integrates cyclic processes, feedback loops, resilient. Find the best natural models, go for a walk, consider both literal and metaphorical models, comb the literature, brainstorm with biologists, identify deep patterns and principles, look across discovered strategies, look at the strategies collectively, specific to your design function. What does each strategy have in common? How are they different? Deepen the conversation. Are you mimicking form? Can you mimic processes? Can you mimic the ecosystem? Ask the question, does the design create conditions conducive to life? And finally, evaluate your findings. Can it adapt and evolve? Thank nature for the inspiration. So this is a picture showing the design evolution. So the conventional one with only few life principles. As you increase more or include more life principles, your design become green to sustainable and to regenerative. Human artifacts tell a story. Look through the human artifacts. Each one of them can tell a story and learn from them. Click this link and listen to this talk. These are some of the references, and there are a lot of internet references also available. Please go through them. If you wish to contact me at this number or email. Thank you very much. This is Dr. Unnikrishnan PC signing off. Thank you very much.